Okay, we continue on some of example. Okay, on the infinite slope analysis. Okay, first we look on Dr. Noli Gofa example here. Okay, so this is the derivation of the equation. Okay, for the tau F, okay, is the shear strength. So this is how Dr. Noli Gofa, okay, introduce the M approach, 1 minus M, okay, times gamma B plus gamma times M times gamma saturated. Okay, while for the new 5.5, okay, so this new should be included in the 5.3 later on to get the full tau F for the shear strength. Okay, while for the shear stress, okay, so W sines beta. So from there, 1 minus gamma B plus M times gamma saturated times Z sine beta cos beta. Okay, so that is for the tau M. Okay. So based on the equations for the 5.3, 5.4, 5.5, and 5.6. So Dr. Noli Gofa has simplified for 5.7. However, this 5.7 it's is capable to be used to solve the problem if the groundwater or the seepage is at the ground surface. Okay. Okay. So in that case, so it is better for us to use 5.3, 5.4, 5.5, and 5.6. Okay, rather than we use 5.7. Okay, so it's better to use, we call as a raw equation. Okay, rather than we simplify. Okay, so I will show you one of example. Okay, where we use this equation directly. Okay, so for the equation where the water is below the surface of the slope, okay, we may use another example from Dr. Kamarudin. Okay, so we look on this example. Okay, so so you need to do some calculation. Okay, so for the 5.3, 5.4, 5.5, 5.6, okay, and then we also can use the 5.7 directly to solve these problems. I guess we have the same result. Okay. Okay. So a long natural slope in a fissure over consolidately is inclined at 12 degree to the horizontal. Okay. The water table is roughly at the surface of the slope. The slope has developed on a plane parallel to the surface at a depth of 5 meters. The saturated unit weight of the clay is 20 kilonewton per meter cube, and the peak strength parameter RC is equal to 10 and phi is equal to 26. Determine the factor safety along the slip plane. Okay, so this is the what we call as this is the input, okay, where beta is 12, Z is 5, M is equal to 1. Okay, why M is equal to 1? Because M is the ratio between the height of the water over the height of the slope. Okay, so for this case, the height of the slope is 5 meter, and the height of the water, where the water is at the surface of the slope, so it means that the ZW is also equal to 5. So M is equal to 1. where ZW over Z 5 over 5 is equal to 1. Okay. Then definitely we use the saturated unit weight. Okay. And the C is equal to 10 and the phi is equal to 26. Okay. Okay. So to start with, we calculate the sigma value. Okay. So we may eliminate this one because 1 m is equal to 1. So 1 minus 1 is 0. Then m equal to 1 times saturated 20 times z 5 cos square beta is 12. So we obtain 95.5. Okay. So that is for the sigma. Okay. Then actually it's better for us to solve the TF first. Okay. Then we calculate for the nu, okay, where the nu is mz saturated unit weight cos square beta. Okay, so 1 times 5 times 9.8 times cos square 12. So we obtain 46.8. Okay, so that is for nu. Okay, for the tau f, C plus sigma minus nu tangent phi. Okay, so we obtain 33.8. Okay, for the tau f. Okay, so that is for the tau f. Okay, now we calculate for the tau m, where the tau m is 1 minus m times unit weight plus m saturated unit weight times z sine beta cos beta. Okay, so we may eliminate the first one. Okay, so we have obtained 1 minus 20 times 5 times sine 12 cos 12. So we obtain 20.3. So tau f over tau m, so the value is 1.66. Okay, so that is for the factor safety for the first for this example. Okay, so by using another equation, okay, the simplified one. Okay, so try to put all the input inside this equation. Okay, what will be the result? Okay, so I give you 5 minutes. Okay. Okay. Is it okay, 5 minutes? Or you can solve it less than that? You just put the input. Okay. For example, for the C, okay, C is equal to 10. Okay. Minus 10 over saturated unit weight times Z cos square beta sine beta. Okay. Plus, okay, there is gamma prime. Okay. So for the gamma prime, okay, so gamma prime actually is saturated unit weight minus with gamma water. Okay, so gamma water you can use 9.81 or 9.8 or 10. Okay, then times with 5 tangent 5 value. Okay, over saturated unit weight times tangent beta. Okay. So what is the answer?
Zero, 50.
Sorry?
5 times 5.
Time 5?
5, yeah.
5?
Gamma answer. Yeah.
Okay.
5, doctor.
So you get
Yeah, the 5.
you get
Sorry?
5. You get 5. Factor safety.
No. No, doctor, I just want to complete the calculation. Just tan phi, I can't remember
Oh,
the
yeah,
value.
pi. Pi value is equal to 26.
Okay, 26.
26.
Answer is 1, is it, doctor?
Prof,
Can you hear me? Hello?
Yes, can.
Yes, Prof.
Sorry, what is the result?
1.189.
1.189.
One
Why
point.
is not same with why it is not same with 1.66?
Yeah, Prof. I use that equal to 5.
5? Which one 5?
Z. The value of
Yes,
Z.
is equal to 5. Yes, Z is equal to 5, correct.
And beta 12 and phi 26.
Okay.
Gamma sat 20 and
Okay.
gamma is equal to 20 minus 10, which
Okay.
gamma water. So
Okay.
I got this answer.
How about
C10.
C10, okay.
Yeah.
Oh, you did not get a 1.66.
Maybe, doctor, I did the calculation all together. Maybe this problem. Because I
Okay.
have to do one by one. Yeah.
It's better to solve one side and the second side.
Yeah, Prof. I think this is a problem. Yeah.
10 minus 20 times 5 times cos. What is the beta? Beta is 12. Okay.
12. Yeah.
Cos beta sine. Oh, there are two cos there.
Or doctor, maybe because I use gamma water equal to 10, not 9.8.
It's okay. There will be no difference.
Okay, doctor.
So I gain 0.5 for the first side, which is the C1. Okay, 0.5. Okay. Then for the other one, 10 times tangent 26. 26 over 20 tangent 12. Yeah, I gain 1.14 here. So 0.5 times 1.14, plus 1.14. So I obtain 1.65 by using this formula.
Yeah, doctor. Yeah.
Betul. So what about 1.65?
Yeah, correct, doctor. Because if we do it separately, it's correct. Yeah.
So Sarah, you previously you gain 1.1 something.
Yeah. 1.189. The first one.
Okay.
Oh,
So
yes.
okay, so means that this formula can be used, okay, but you need to make sure that the problem where the seepage or the groundwater is located at the surface of the soil.
Surface.
Okay.
Yeah.
Okay, then we move to another example.
Doctor, I have a question.
Okay.
I saw that from equation 5.4 and 5.6, they have a gamma B.
Okay.
What does that mean for the gamma B?
Gamma B is they call as a bulk unit weight or Morse unit weight or unit weight. So for this case, the unit weight or the gamma B is equal to okay, because this it doesn't, because it is fully saturated, so we may not use the value of the gamma B.
Okay.
So gamma B is the gamma of the soil above the ground water. They call it as a gamma bulk. Okay. So the 5.7, okay, is only can be used if the groundwater is at the surface of the soil. Okay, however, 5.3 up to 5.6, okay, we can call it is a very powerful solution, okay, where we can solve for any problem which the groundwater level located between the surface and the failure surface. Okay. Okay, now we move for another example before we end our class. Okay. So this is based on Dr. Kamaruddin reference book. Okay. So he use the same approach with N, okay, but slightly different, okay, where I guess the M equation is more a universal approach. Okay, however, for Dr. Kamarudin, he introduced four type of cases, okay, where for the 3.1 to 3.4, okay, it only suitable to be used, okay, when the cohesive soil without a seepage case. Okay, so this is without a water. Okay, so when the cohesive soil with seepage parallel to the slope surface, okay, so we need to use the equation 3.5 to 3.8. Okay, so the other one for the granular soil, okay, where there will be no C value for the S. Okay, this is tau F. Okay, while this is tau M if we refer to Dr. Noli equation. Okay, so this is the shear stress, while this is the shear. This is the shear stress, while this is the shear strength. Okay, so for the granular soil, it doesn't have any C value. Okay, so we use 3.9. Okay, granular soil with seepage. Okay, so without seepage, so there will be no saturated value. Okay, okay. So that's why the M value is much more universal. Okay, much more because we only use one approach. Okay, while Dr. Kamarudin approach, okay, it based on four different cases. Okay. However, the example that's been shared by Dr. Kamarudin, okay, so it can be beneficial for the M approach. Okay, we may go through this example, and then we may try to use the M approach. So first we look on the first example. Okay, it's a straightforward example here. Okay, figure Q31 illustrates an infinite slope of C and Phi soil. Assuming the groundwater table is far below the slope surface, calculate the developed shear strength S and the shear stress along the failure surface. Okay. So if you want to use the equation by Dr. Kamarudin, so we may look on equation 3.3 and 3.1. Okay. So we may use 3.1 to 3.4, okay, because it is a cohesive type of soil. Okay. Okay. So then S is equal to C plus sigma tangent phi. Okay. Then we put all the equation. Then we put all the input, and then we obtain 43.4. Okay, for the S. Okay. Then for the tau, okay, gamma H sin I cos I. Okay. Then we obtain 15.4. Okay. So S over tau, okay, the factor safety will become 2.82. Okay, so the factor safety is 2.82. Okay, so now we look on the example from the slide. Okay, by using the simplified method, okay, from the dust. Okay, we share the slide. Stop sharing. Okay. Okay, so this an example for the slope where the groundwater level is far from the failure surface. Okay, so you may use your calculator and then try to calculate based on Dr. Kamarudin example. Okay, what is the factor safety value? Okay, Okay, first you write down first the equation. Then now we switch to Dr. Kamarudin example to get the input. Okay, so C over gamma H cos square beta tangent beta or plus tangent phi over tangent beta. Okay. Okay, then I will switch to Dr. Kamarudin example. Stop. Okay. So we use the input from Dr. Kamarudin. Okay. The value of C is equal to 20. Okay. So 20 over. Okay. So okay. So gamma is 18. So this also gamma B, gamma B, gamma bar. Okay. So 18 is the gamma. H is equal to 5 times cos square beta tangent beta. So beta is 10. So cos 10 tangent 10. Okay. So for the first side is equal to 1.29 or 1.3. Okay. So 1.3. Okay. Then the other one is tangent phi, which is equal to 15 over tangent beta, which is beta is equal to 10. Okay.
The answer is Prof 2.82.
Yes. So 1.293, 1.299 plus 1.5 is equal to 2.82. Okay.
Two. Yeah.
So it's similar with the one that we have calculated in Dr. Kamarudin example. Okay. So means that the simplified from the dust equation. Okay. So it's suitable to be used for when the water is far from the surface. Okay. So that is for the first example. Okay. So now we move to the last example. Okay. So determine the safety factor against sliding, assuming the interface friction angle between the sliding and the stationary subsoil is 20. So this is the phi value. Okay. So for this case, okay, we can use directly the equation from dust. Okay. And also we can use the equation from Dr. Kamarudin. Okay. Yeah, I guess most of you already know. So the value is 1.5. Okay. 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 Then for the B, okay, determine the critical height of the slope. Okay. So the critical height of the slope, okay, if we base on the Kamarudin equation, okay, so we need to put the shear strength, okay, on the left and the shear stress on the right. Okay. Then we rearrange where we put the H on the left and the rest will be on the right. Okay. So based on this equation, okay, the total or the critical height, okay, is equal to 21. Okay. So actually the HCR is equal to the equation that that shown from Dr. Kamarudin equation. Okay. So this is Dr. Kamarudin equation. okay, I will switch to Raja Mdas equation. Okay, for the HCR. Okay, so this is from the Braja Mdas equation. Okay, so if you use this equation straightforward, okay, you can get also the HCR is equal to 21. Okay, so you have two options here. Either you want to use directly this equation, okay, and then you compare with the result with Dr. Kamarudin approach. Okay, but for the knowledge, to enhance your knowledge on this matter, it is better for you to use from Dr. Kamarudin equation. At least you know how the derivation of the HCR. Okay. Okay. So that is for the second question, or from the question number 2. Okay. So the last question, okay. So the last question, okay, this is you can try to use the M, okay, the M approach. Okay, determine the safety factor against sliding if the groundwater table is at 2 meter below the slope surface. Okay, so means that the groundwater level is 2 meter, okay, or the height of the groundwater level from the failure surface is 4 meter. Okay, so previously, based on Dr. Noli Gofar approach, she doesn't show any example where the groundwater level is below the ground surface. Okay, so for this case, okay, you may try to use the M approach, okay, rather than and then compare with the Dr. Kamarudin calculation. Okay. Okay, we look on this example first, and then we try to use the M approach. Okay. 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 When the water has submerged the soil, okay, the new saturated unit weight is 19, and assume other parameters are unchanged. Okay. So the saturated unit weight is equal to 19. Okay, for the 4 meter submerged soil, and for the 2 meter below the ground is equal to 17. Okay. Okay, for the S equation, okay, C is unchanged, okay, plus sigma tangent phi. Okay, so for the sigma, okay, we may use the equation which is what we call as the effective unit weight times H. Okay, 17 times 2 plus 19 minus 10 times 4. Okay, this is the effective stress calculation, equal to 70. Okay, then include the 70 and all the other parameter inside the equation of S. Then we obtain 50.93. Okay. While for the tau or the shear stress, okay, since water cannot resist shear stress, okay, so because this tau is happen at the failure surface, okay, at this area, okay, so the full saturated or the unit weight should be considered as a full saturated unit weight, okay, because since water cannot resist shear stress, okay. So reader may refer to other reference for the derivation. Okay, then we'll look on Dr. Noli Gofar example later on. Okay. So 17 times 2, okay, plus 19 times 4, okay, times sine 25 cos 25, then we obtain 42.13. Okay, so the ratio between S and tau is equal to 1.21. Okay, so that is for the example from the third question from question number 2. Okay. So if we want to use Dr. Noligova approach, okay, okay, for the M, okay, in this case, M is equal to 4 over 6, okay. So you may calculate 4 over 6, okay. 4 over 6 is equal to 0.67, okay. So 1 minus 0.67 times gamma bar, where the gamma bar is equal to 17, okay. Gamma bar is equal to 17, okay, plus 0.67 times gamma saturated, which is 19, okay, times Z is equal to 6, okay, cos square beta, where beta is equal to 25. Okay, so that is for 5.4. Okay. While 5.5, okay, M 0.67, okay, times Z is equal to 6, okay. Gamma water, we use 10 because Dr. Kamarudin used 10 in his example. Cos square beta, where beta is equal to 25. Okay, let me calculate for the sigma first. Okay, 1 minus 7, okay, times gamma beta, gamma B 17, okay, plus 0.67 times 19. Okay, so we get 18.34, okay, times Z is equal to 6 times cos square 25. Okay, cos 25, cos 25. Okay, so 5.4 is equal to 90. Okay, 90.4. Okay, I need to write first. 90.4, 90.4 for the sigma. Okay. While for the new, okay, 0.67, 0.67 times 5 times 19 times cos 25 is, sorry, Z is 6, cos 25, cos 25. Okay, 62.7 for the new. Okay, then for the tau M, 1 minus 0.67 times 17 plus 0.67 times 19 times 6 times sine 25 cos 25. So 42 42 for the tau m. 42.1. Okay. So then we use this equation, C is equal to 30 plus 90.4 minus 62.7. Tangent phi is equal to 20 over 42.1. So we obtain 0.95. Okay. Wait, or 1.21. Okay. So I'm not sure where is the cause of difference.
I think the mu is 32.23.
32 32. Okay, mu. So it's 0.67 times 6 times 10. Cos 25, cos 25. Oh yeah, 33, yeah. 33, sorry. 33. Okay, again C 30, sorry, 30 plus 90.4 minus 33 tangent 20 over 42. Okay, yes. I got 1.21. Okay. So means that we can use the approach from Dr. Noali, okay, for this same problem from Dr. Kamaruddin for the C, okay. So I guess for the infinite slope, okay. So either you to determine the critical height, okay, or if they provide for the factor safety value, okay, you need to determine any other parameter, for example, gamma, C or phi. Okay, so that will be possible question, okay, for your project or for your assignment. Okay, because if I give you a straightforward problem, so I guess easily you just use all this formula and put the input inside the formula. Okay. Okay. I guess that's all for today. Okay. So tomorrow we may continue for the finite slope. Okay. We just see how much I can cover, how many topics I can cover within 2 hours, because I need to arrive at Melaka around 12 a.m. 12 p.m. Because the standard of procedure for the school is very tight, so we need, due to the COVID problem, so we need to arrive within 12 to 1 p.m. Okay, because my son need to do the saliva test. Okay, if negative, yeah, if nothing problem, so I can back after that. Okay, so that's why I need to finish by 9. Okay, so okay, we meet tomorrow at 7. Okay, so that's all for today. if you have any problem, you can just put in the our WhatsApp group. Okay. So see you tomorrow. Okay. Assalamualaikum and good afternoon.
Good afternoon, Dr. Wa alaikum salam.
Thank you, Doctor.
Thank you, Dr.